as I was saying that this is the order of the atoms in group 2. First beryllium, then magnesium, then calcium. As we go down the group, the size increases, and hence smaller the size of the cations, more will be the covalent character. Hence beryllium chloride will have more covalent character as compared to magnesium chloride, and magnesium chloride's covalent character will be greater than that of calcium chloride, because calcium chloride has got the greatest side among them, right? And greater the size of the cation, less will be the covalent character. Now let's have a look at this example and pause this video and try to solve this by yourself. Now you will have to find out which compound has got more covalent character. We have sodium chloride, sodium bromide, sodium iodide. Here if you see, the cations are same, but the anions are different. So here we would be focusing on the anions. All of them are halogens, right? So their order is, first comes chlorine, then bromine, then iodine. And again, as we will go down the group, the size increases, right? And in case of anions, greater the size, greater would be the polarization, right? So in this case, the covalent character of sodium iodide would be more than that of sodium bromide, and the covalent character of sodium bromide will be greater than that of sodium chloride, because in case of anions, greater the size, more will be the covalent character. Okay, they all are halogen groups belonging to group 17. So thereby we conclude two important things from Fazan's rule. Obviously, if the covalent character increases, the ionic character decreases, because the percentages would be like, the amount would be the same. So suppose you have a cake, right? So the more part of the cake you give it to your friends, the lesser would be left for you. So similarly, if in any compound the bond of the covalent character increases, so definitely the ionic bond will increase, right? So few conclusions we have come across: more the covalent character, solubility will decrease. The reason, covalent is a weak bond, right, compared to ionic bonds. Ionic bonds are very, very strong. So since covalent is a very weak bond, so it is very easy to break them, isn't it? And since they can be broken very easily, so they get soluble very easily, right? And even the melting and the boiling points would be low if the covalent character is more. And the another most important point is the color. More the covalent character, more would be its color imparting nature. So let's have a look at a question which will have higher melting point. Try to do this sum by yourself. I told you, you just need to find out whose covalent character is more, because more the covalent character, less will be the melting or boiling point, right? Or you can find it the other way around, which one of them has got less covalent character. In that case, its melting point will be higher. So you have beryllium fluoride and a magnesium fluoride. Here the anions are same, so we need to focus on beryllium and magnesium. We know in the periodic table beryllium comes before magnesium, so we need to see the cation. Down the group, the size increases, so obviously this one will have more covalent character, right? So covalent character of this will be greater than this, which means its melting point will be less than this. Try to understand, more the covalent character, less the melting point. This will have more Cc than this one, so hence its melting point will be less than this one. Therefore, the melting point of magnesium fluoride will be more than beryllium fluoride. Again, let's have a look at this one. Calcium chloride or calcium bromide. Here the cations are same, but the anions are different. Chlorine and bromine are halogen groups, group 17. So first comes chlorine, then comes bromine. So here, as we go down the group, the size increases, and in case of anions, I have told you, greater the size, more will be the covalent character. So between calcium chloride and calcium bromide, the covalent character of calcium bromide will be more, therefore its melting point will be less. Therefore calcium chloride will have more higher melting point than calcium bromide. Okay, This is a very important question, and it has also come in one of the entrance exams. Which one will have higher melting point? Sodium chloride or copper chloride? Now, we need to see, I already explained you, Cu plus has got that pseudo noble gas configuration, and you know the elements which have got pseudo noble gas configuration, without a doubt they will have more covalent character. So therefore, since the anions are same, so Cu plus has got pseudo noble gas configuration, so it will have more covalent character. More covalent character means less melting point, right? Covalent character and melting and boiling points are inversely proportional to each other. So hence, definitely, since it has got less covalent character as compared to this one, so this will have, sodium chloride will have more melting or boiling point as compared to copper chloride. Again, coming to KCl or AgCl, again Ag plus has got pseudo noble gas configuration. Please memorize those 6 elements which I have explained you. You have copper, you have silver, you have gold, then you have Zn, then you have cadmium, and you have mercury. So these 6 elements have the pseudo noble gas configuration. So here again Ag plus has got PNGC, which means more covalent character, and more covalent character means less melting point. So KCl will have higher melting point as compared to AgCl. Which is more soluble? Try to do this by yourself. Ferric hydroxide and ferrous hydroxide. Ferric means Fe3 plus, ferrous means Fe2 plus. Wait, ferric Fe3 plus, ferrous Fe2 plus here. So as I told you about the solubility, greater the